Hey y'all, welcome back to Database School. In this episode, I'm talking to the co-founder and CEO of Tigris Data, Ovais Tariq. Ovais spent 6 years at Uber, scaling, petabytes of data, building actual data centers, talking to chip manufacturers, the whole deal. And then he and some of his colleagues left to go found Tigris Data. And Tigris is interesting because they're taking on one of AWS's best products, S3. So Tigris offers an S3 compatible API, but they do a lot more on top of that. So Tigris is putting your data where your compute is. There is no concept of regions with Tigris. They just get your data where it needs to be. It is a global region, and then they will, behind the scenes, handle getting your data where it's supposed to go. So we start out with a bunch of nice war stories from his time at Uber, and then we talk about the challenges of building distributed storage and doing smart caching and distribution and rehoming of data. This is a very interesting one, so I hope that you will stick around and enjoy this entire thing. If you like this episode, please subscribe to the channel or leave a podcast review or rating or whatever in your podcatcher of choice. That would really help me out. You can also go to databaseschool.com to find past episodes, and depending on when you're listening to this, you can find all of my database courses there. I hope you enjoy this episode. Now let's get to it. I am here with Ovais, the co-founder and CEO of Tigris. Ovais, do you want to introduce yourself a little bit further?
Yeah, as you said, I'm co-founder and CEO of Tigris Data. Tigris is a object storage service that's S3 compatible, and we can talk more about it. You said my intro, so I'll just talk about myself first. I've been in the data infrastructure industry for around 20 years, and majority of that time I spent working with databases, so either building databases or operating databases at scale. And Tigris is actually the first company that is not entirely database related. I mean, S3 is sort of a database as well, it's a key value store, but it's not, you don't think of it as a traditional OLTP database. So all the experience prior to that is more on the database side of things. I have worked at Percona as well. Percona is a well-known database company.
Yeah.
And I spent 6 years at Uber. I built out Uber's storage infrastructure. There are a few blog posts about some of the work that was done. So there's a distributed database at Uber called Dockstore, which is the primary online database that stores close to 100 petabyte of data. It's probably the second biggest online database store after Facebook. I'm not aware of anyone else doing it at that scale. So spent 6 years at Uber. Ended up building a bunch of distributed systems. Learned a lot over there. Uber was running its own data centers, and then initially Uber was buying Dell and HP hardware, but then ended up building their own hardware as well. So I learned a lot all the way from building distributed systems, operating at that scale, and then also on the hardware side, like what does it take to operate a data center? What does it mean to actually build your own hardware? And then that transition, all of that knowledge and experience, and transition into starting Tigris with two of my other colleagues, Himang and Evgeny from Uber, and we have worked around 6 years at Uber together as well. That's kind of a short version of what I've been up to over the last 2 decades or so. Happy to dive into detail.
That is a short version, because in one of the previous episodes I talked to Sam Lambert, and we were going back and forth on Twitter, Sam and I, and then you chimed in, and Sam texted me and was like, "Oh, dude, you gotta talk to Ovais. He is wicked smart." So I want to get to Tigris, the company that you and your friends founded out of Uber. But first, I want to talk a little bit about what you all did at Uber, because if I'm reading correctly, it was like many hundreds of petabytes potentially across, the whole of Uber. And so talk to me a little bit about what you all built inside of Uber and kind of like what your realm of responsibility was. You said you went all the way up to like the data center,
Yeah.
but what was your like purview inside of Uber, and kind of what kind of scale did you see through over there at Uber?
Yes. So I was in this group called storage infrastructure. It's like online storage infrastructure, where the responsibility was dealing with all of the online OLTP databases. And we had our own flagship product like Dockstore, which was an in-house database, and then we had a MySQL service offering. We had a small Postgres offering as well, and some Cassandra. And then on the caching front, there was Redis, and some other services which are more for developer experience purposes. Some abstraction layer on Dockstore providing a ledger style access, but it was mostly around online databases, online infrastructure that was responsible for serving online traffic, whether it's Uber Eats, Uber Rides, or Freight. So imagine the criticality of the service, that if there was any incident, any outage, you could not order Uber Ride, or you could not order Uber Eats. And there were some incidents that had happened like that. Once there was an incident during Halloween as well, where one of the Cassandra clusters went down, and people could not order anything for a few hours on Halloween. So this wanted to give that as an example of what we were dealing with, like, business critical services. Uber had this philosophy of building things in-house. So that's why Uber was not using cloud. And the TK, the founder of Uber, thought of Amazon as sort of an adversary, because Amazon was not AWS, but Amazon as a whole, and what Uber was trying to do. So that was initially the reason for not going to the cloud. But then eventually the idea was that we're going to build out our own infrastructure. Then Uber was also venturing into autonomous cars, and that could not have been done on top of the cloud. That the type of scale and the type of real-time infrastructure that was needed required us to have our own specialized software and hardware. So as the company was tech forward at that time, going in that direction, most of the things were getting built out in-house. So that's why the database that was powering all of the online transactions happening at Uber, that was also built in-house. And initially, as I mentioned during the intro, initially we were using stock hardware, but when you're operating at that scale where you're storing hundreds of petabytes of data, then you have to look into how do I make this hardware more cheaper, more efficient? And by going to working with the chip manufacturers ourselves, and designing our own hardware and rolling that out, Uber was able to reduce the cost by a factor of 2, which is huge. At Uber scale, that's a huge reduction in cost.
This is interesting to me because it sounds like it started out like you said, we built everything in house, which, as a developer, I'm like, heck yeah, I love building stuff in house. But it's interesting that it started out as like a kind of like a rivalry business decision, and then turned into a performance decision when you talked about the autonomous vehicles. And then you went as far as building out not only racking your own servers, but you said you're talking to the chip manufacturers. So like, what are you trying to squeeze out at that level when you're going to chip manufacturers? This is like 2 orders of magnitude beyond anything I've ever done. So you're going to have to guide me through. When you go to a chip manufacturer, what is it that you're trying to do there?
So imagine it this way, that it's not that you're only putting our own racks into cages that provider like Equinix or CodeSite is providing. It's more that we are leasing an entire building, right? So we are responsible for power distribution maths, like how much power can we put, how much power density can we have on a rack, and we are trying to optimize rack density, optimize the amount of space that we are using so that we can serve more workloads out of a smaller space, so basically conserving real estate. So when we are making those type of decisions, then we have to talk to the chip manufacturers to see how can we improve cooling, how can we improve cooling so that the hardware that's placed in a rack, it can sustain more power. So when we are looking at those things, then it's important to talk to the chip manufacturers and try to build out custom servers so that they are in a smaller form factor. We can have more and more servers stacked in a single rack, and we are thinking about thermal and cooling properly, and all of that requires going back to the chip manufacturers or server manufacturers and working with them to design something custom.
That's incredible. So what is your
and there were some other things so on the density side, some other just to add a bit there, there were some other things as well on the density side, like I remember we used to of course, there are other peer companies like Facebook, and we used to see what they are doing and talk to their database team as well, and we ended up running much more denser storage per server than SSDs, in the amount of SSD space per server than what Facebook was doing at that time. So we were pushing this density thing forward at the time. And if you look at what's happening on the GPU side of things, the same conversation is happening right now. Like, how can we have more power density per rack so that you can have more GPUs sitting in the same rack? And we were not pushing it for GPU purposes, but we were pushing it more for real estate efficiency at that time. But all of that requires going back to the source and talking to them and getting something that's different from a stock configuration.
God, that's so awesome. I can mentally assent to the fact that like Uber and Facebook and like these huge companies are doing this sort of thing, but I've never talked to anyone who actually was there. So this is great for me. So what is your how do you get there as an individual? What is your background? Because I imagine you're like running databases, some sort of computer science engineering, and then suddenly you're like, all right, now I'm, I guess, mechanical. Like I got to think about power density and getting power and cooling. And now I'm setting up hardware and I'm running data centers. That feels like a steep learning curve to me. So how did you navigate that just as like upskilling yourself?
That's definitely, that definitely requires different type of skills, because I had experience with the hardware, but not at that level. I was more, even when talking about database, I was experienced more with the software side of things, right? And not generally the hardware side of things. But the talent density at Uber was just amazing, and it's not like I was doing everything, but I was working with colleagues who were involved in designing or making these decisions around thermal and how cooling is going to look like, and where should the processor go on the motherboard, what U to use, what should the network gear look like. So there were a lot of experts, of course. There were there was a big team that was designing the hardware, and we were working with them, making sure that they understand what our requirements are. And so it wasn't just one man show. It was many really smart people working together to make this happen.
God, that just sounds like the heyday. It just sounds like the hyperscaling glory days of Silicon Valley. That is so fun that you got to be there and be so involved with that. What happened when Halloween rolls around and everybody's drunk and Uber goes down? What happened? Like, what was the root cause? What did y'all do? What was the outcome? Like, how did y'all handle that?
I cannot go into a lot of the details, like deep details. It was some load related issue on the Cassandra side. Cassandra has a lot of half-baked features. There are two most common problems with Cassandra that we faced. One of them was around large partitions. So if there's a partition that grows large, the whole cluster crashes. Materialized views is a half-baked feature. Sometimes that would crash under load as well. So it was just the fact that we were using Cassandra, which is not really a good product, and it failed at the wrong time. And it had to be manually
Probably.
resurrected. Like it wasn't something like, okay, just restart the node and everything is fine. The cluster was
Yeah.
having trouble, so it had to be manually resurrected, and that took time.
Oh man.
But it was a big
Were you,
incident, is like because you had to go in front of the CEO and talk about why it happened and how to prevent it from happening again in the future.
that does not sound like very much fun. How many data centers did you help build out at, during your time at Uber? I just don't even know the scale of Uber's hardware. So how many around the country, I guess around the world, did y'all have?
There were a few different. I cannot talk about the exact ones, but there were a few different data centers in US. And Uber had launched by when I joined Uber around that time. Uber had launched in China as well, and in 6 months, team built out. That was before that predates me, but in 6 months, the team actually flew to China and built out two data centers there, and on two data centers online in 6 months and serving traffic and some of the cities in China were day one doing traffic more than San Francisco, and San Francisco used to be the most traffic density city we had. So it was enormous scale. Of course, then Uber ended up partnering with Didi and shutting down the Uber business there. But yeah, the China data centers were growing crazy, and then the data centers that existed in the US.
Man, that is so fun. I could spend forever talking about all this, these war stories of Uber. But what I want to transition to is eventually you came out of Uber. So you and some friends, you did, I think you said 6 years at Uber, operating at this massive scale, running these massive workloads. And then what happened? Did you all have a bright idea? Did you see a hole in the market? Like, what was the inciting incident where you were like, hey, we did it. We conquered the world. Let's go do something else.
Yeah. So at Uber, so as we were discussing earlier, everything is built in-house. Uber has sort of its own cloud, so you get the experience of how you would build your own cloud, and you sort of get the experience of building something globally. So we thought that we can build a global platform outside as well, and because storage or databases is our area of expertise, we thought of this global storage platform that we could build outside that would simplify running workloads across regions, across multiple clouds. That would be intelligent in the sense that you don't have to specify the region where the workload is running. It would dynamically move the data around and make sure all access everywhere is local. So kind of like if someone is building a product that requires that level of global access, they would need a platform like that. So that's that's what we started off to build at Tigris.
Yeah. So talk to me. Talk to me about what Tigris is right now today, and then compare that to what you set out, and talk me through any like changes of path through there. So start with today, and then let's work backwards.
So Tigris is a globally distributed object storage service that's S3 compatible, but its architecture is fundamentally different from S3. In a traditional cloud, there's a concept of a centralized region, all the compute, all the application. You pick a region, all compute, all applications, all data is stored in that particular region. With Tigris, it's all decentralized. It's all distributed in the sense that you have one region which is global, and Tigris basically takes care of doing the data placement in a way where wherever your compute workload is running, the storage is always available in a region local manner. So if your compute workload is running in San Jose, then the data is placed in San Jose. If the compute workload is running Frankfurt or in Ashburn or Chicago, the data gets placed dynamically over there. If the workload changes over time, the data placement also changes over time. So you get this nice property of region locality wherever you run the workload. That's the core principle behind what we are doing at Tigris, and then that's one part of the changes in architecture that we brought in, or how we think about the storage. And then there are other uh, uh, things that we're also doing that are different from S3. So for example, the way we have built object store, it's a mutable store, so there are no mutations that happen in place. Think of it as a log, right? And the live bucket is just like a materialized state of that log. And that gives some really nice properties, such as you can take if you have used ZFS, or then similar to ZFS gives nice properties, as in you can create snapshots, which are really cheap. So you can have like a petabyte bucket, and you can instantly create a snapshot. It's basically a point in time marker in that write ahead log, which you can always go back to if you want to go back to a previous state of your storage, or you can fork from that snapshot and create a separate timeline. So we are but these two changes that I described, the removing the concept of regions, and providing this immutability and ability to fork and create snapshots. These seem like two different features, but they are under the umbrella that these are being built is how do we improve the developer experience of storage, and taking into view the modern applications, primarily focusing on the AI related workloads, or the agentic workloads, primarily focusing on that. But how can we improve the developer experience, remove most of the friction, make it basically storage configuration free?
Was this your vision when you left Uber with your co-founders?
No,
To build this?
No. This
Did
was
you
not the
discover
vision.
this along the way? Yeah. So what was your vision, and how did you discover this global storage thing?
Yeah, so I think most of the times when you start off from a large company, the vision is different, and to build a startup, the vision is different. Then reality hits you, and you end up doing
Yeah.
refined version.
That's
of
what
it,
I
right?
assumed. Yeah.
So when we left Uber, we wanted to build a similar distributed database platform like we did at Uber. So at Uber, I talked about Dockstore. So Dockstore is this sharded, document-oriented database with built-in caching, can do millions of QPS, built-in search capabilities. You can do full text search. So it provides you this platform which you can do streaming, which can do search, which has caching built in, and is OLTP. That's something that Uber needed. Uber, because there were 5,000 microservices, and you don't want engineers to worry about infrastructure at all. So you hide away all of that infrastructure behind an abstraction layer, right? That's what we did there. So when we started off, we said, okay, like, we'll build the same thing, and that's what people want outside. But there are not that many scale related use cases like Uber had. So it's not something that people wanted. And as we started, as we started working with people, doing the market research, and talking to people who, we just got the sense that we need to go lower down the stack and focus on storage and solve, the DX problem on the storage side, and that's where we ended up with object storage.
How long has Tigris been around now? So how long has that journey taken?
So Tigris has been around for almost 4 years. So at the end of this year, it will be 4 years.
That's a pretty big shift to go from distributed database to object store.
Yeah, it's a big shift. But if you think about it, like object store also is a distributed database. It's just it's more. It has a more simpler API. Like there are no transactions like KV API, right? But it is still a sort of a database with a different API, with a different type of workload. It's not point lookups or small ranges. It's people scanning the data, reading gigabytes of data. But essentially, it's a sort of a database. But the market segment is different. The type of applications that are being built on it is different.
So talk to me about that because S3 exists,
Yeah.
right? And I just read like last week or 2 weeks ago, there was something on Hacker News about how S3 does it. And it was like, oh man, that's incredible. S3 is very good,
Yeah.
but you are out there building this distributed database. You're talking to customers and they're like, hey, we actually need something different. And then you and your co-founders come up with some of these innovations, some of which we've talked about, some of which we haven't. But what is that use case, that pain point where the customers are like, hey, we actually need you to build something similar to S3, but fundamentally different? What is that workload?
Yes. So S3 is one of the best services that has come out of AWS, right? So S3, EC2, probably DynamoDB, like these are the three top services that have come out of AWS. All the other services, all the other hundreds of services are probably not that good. And for example, their database offering cannot compete with PlanetScale. But S3 was the first, I would say, true serverless, experience, right? When you're using S3, you don't worry about any capacity planning, don't worry about operations. You can have 1 terabyte of data today and you can grow to a petabyte of data tomorrow. If, there's no capacity planning that you would have to do. So that's like true serverless experience, right? And S3 has done really well. I mean, 80%, when we were doing the market research, we found out that, 80% of the market share is, or close to 80% market share is S3, and tens of billions of revenue just from S3, right? So it's a huge undertaking for sure. Right? But
yeah, bold move going against that. So I'm excited to hear the reasoning.
It's a huge undertaking for sure, and it's different from other companies. So other people are also solving infrastructure problems, but when you're solving a infrastructure problem on a cloud, you are saved from some of the low level challenges. But we are actually solving it all the way to the metal. We can talk about it later on. Like, we are not running on the cloud. We are running in our own data centers. We are installing our own hardware. So we are going all the way down. So it is a big undertaking to take, as compared to someone like AWS or S3. But what we have found is, especially with the AI workloads, is that computing is getting more distributed. So you are seeing CoreWeave getting successful. You're seeing Lambda Labs, Crusoe, even Oracle Cloud. All of these getting successful because computing is getting more distributed. And what we have seen is that, especially the folks building AI applications, they are looking for specialized services. The reason they use CoreWeave, the reason they use Lambda Labs or Together AI, is because these providers provide much faster performance. Their hardware is specialized. Their networking is specialized. So people are looking for specialized services. But when your compute becomes distributed, your storage cannot be centralized. Storage has to be distributed as well. So that's where the need for something like what we are building comes out. Like, if you want your compute to run in CoreWeave and Lambda Labs, and you want them to run in Midwest and East Coast, your storage has to be moving around dynamically to be in the same region where your compute is. And that's why we're seeing the adoption of Tigris. Like, all of these users of neo clouds, they are looking for a storage solution, the type of storage solution that we're building, and we are seeing success with them. The well-known media gen companies are already, our customers are already using us, like World Labs, FAL, Kriya, like Hedra, like all of these well-known companies that are building their own models or providing top-notch inference platforms. They have become customers for exactly this reason, that they have distributed compute, they need distributed storage to work alongside their distributed compute, and that's what our architecture enables.
So the leading indicator was the growth or utilization of this distributed compute. And then everybody's like, well, we've got our compute everywhere, but all of our storage is on the East Coast of the United States. And that's not going to work long term because, like you said, there's a lot of data being schlepped around but with these AI companies.
Yeah.
Is that right?
Yes. So not only in locked into one region, but locked into AWS as well. AWS makes
I
it
see.
expensive, like 4 times
That's right.
expensive to move to use a service outside of AWS. Right.
Got it.
So
So we have both a technical and a business
yeah.
reason to get out of S3. Okay, I see. All right, so that makes sense to me. Still a bold undertaking to go against S3, but I love it. Talk to me. Let's do a high level overview of the stack, because you said we're not on a cloud, so that's all the way at the bottom, and then all the way at the top, your S3 compatible endpoint. So just talk to me, just a high
Yeah.
level, like what is Tigris built out of, and then we can dive in on one of the slices.
Yes. So at the top of the layer is, as you were mentioning, S3 API layer, S3 gateway. It's a stateless service that's responsible for authentication, authorization, logging, request handling, all of that, and request routing. Then there is a caching layer. So one of the advantages that we say comes with our storage is, automatic caching of frequently accessed data that's optimized well for small files, which is what typically AI workloads look like. So, we have this caching layer that's built on top of RocksDB. Then we have a metadata layer, which uses FoundationDB. FoundationDB is a distributed database. So there are multiple FoundationDB clusters. The metadata of buckets, is sharded across those FoundationDB clusters. And then we have erasure coded storage, which is basically what's responsible for ensuring that the bytes are written on the disk correctly. So those, I would say, are the major pieces. And then the other things like replication, like the background job framework, which is responsible for doing async work, replication from one region to another. But these are the main pieces, and all of the database needs are served from FoundationDB. So whether we are building our own replication, whether we are doing work scheduling, whether we are building secondary indexes, like we have built that all on top of FoundationDB. So yeah, FoundationDB is sort of kind of the core.
Yeah, let's start there. Tell us about, for the people who haven't used or maybe haven't even heard of FoundationDB, give us a little, sing the praises of Foundation, because it sounds like you all are relying on that very heavily. So what was the, why did you choose that one?
So FoundationDB is a strongly consistent transactional key value store. It provides serializable isolation and multi-key transactions. It only exposes a key value interface. It doesn't have any SQL interface, but there is no concept of any shard boundary. When you're using FoundationDB, you can batch any key together, any read-write operation touching any key together into a single transaction, and get serializable consistency. So we needed strong consistency, and we needed a database that can scale horizontally. Like we want to be able to just keep adding nodes and it can keep scaling out. So we needed that elasticity, and we needed that consistency. And then we also needed something that we could trust on, right? So one option was to build out something ourselves. Like we already built a database at Uber, why not build it ourselves? But then you would have ended up spending all the time building a distributed database rather than building an object store. Because if you're building a database from scratch, I mean, it's going to take 3-4 years for it to become, to come to a stage where you can actually, trust it. It takes time to build that. So the best option that existed, and because we didn't need a SQL layer, so KV layer, KV sort of a layer was perfect for us. So the best thing that existed in our eyes was FoundationDB. It's not that well known, but it's actually proven at scale. So it's like one of the cornerstones of Snowflake. Snowflake uses it heavily. All the metadata there gets stored in FoundationDB. iCloud, Apple's iCloud, that's built on top of FoundationDB. And iCloud is another example of a global storage product because the users are global everywhere. VMware uses it, Adobe uses it. Like people don't talk about it much, but there are many large deployments of FoundationDB. And then FoundationDB has an interesting concept of simulation testing. So it's actually the only database that I know that I know of, and there might be others that exist, but they're the only database that I've come across that invests so heavily in testing, uh, where they do all kinds of things like simulating network failure, simulating disk failure, simulating bit rot. Like all of these kind of failures are baked in the failure mechanism baked into the product to be able to test it the right way, and that further increased our confidence in the product. So those are the reasons we went with FoundationDB. We wanted a strongly consistent metadata store, so you can provide strong, read after write consistency guarantees for metadata, and we wanted to be able to scale horizontally. So that's why we went with it.
So instead of spending 3 years building something that you could then use to build the actual thing, you picked the battle hardened, the one that's been tried and true and tested. And I think you will love this. I think the SQLite rewrite Terso has taken a lot of inspiration from that simulation testing, and they're starting to do a lot of that.
Yeah. Thanks for bringing that up.
They're inspired by that. So talk to me about, I want to get through like the life cycle of a request, but before we do that, talk to me about the metadata store, because you're storing two things, right? You're storing the blob, you're storing all the images, the photos, the models, the videos, whatever, and then you're storing information about that. You've got the metadata and the actual storage. Talk to me about how those things interplay, because you've got one region, I guess anything could be anywhere. So how are we keeping those two things synced up?
Yeah. So there is a concept of two types of metadata. There's a global metadata, and then there is the region local metadata. So a global metadata is I can start global metadata. Global metadata is basically a pointer to where the data actually exists.
On
because
a
like
disk
you said,
or disks somewhere.
Which region it actually exists in.
Okay.
So think of it this way, that if we are in 6 regions, we have 6 different regional metadata stores that are responsible for metadata of that particular region. And then there is the global metadata. Because the request can come to any region, and that region transparently has to route to the owner of that data, so all of them need to know where the data exists. And global metadata's responsibility is to provide that pointer, so that if a request for object stored in Frankfurt is received in London, then the London gateway can route it to the right region. So that's the global metadata. And then the second metadata is actually metadata about the object, which includes things like checksum, or other things that get stored alongside the object. So for example, ST is a concept of object metadata, where the user can store anything arbitrary alongside the object, and then it includes the pointer to where physically on disk the data gets stored.
Gotcha. So the global metadata is pretty thin. It just gets you to the right region, and then the regional metadata contains the richer stuff over there.
Yeah.
Okay, that makes sense to me. Now, I kind of want to talk about a request.
Yeah.
So let's say I'm in Dallas, which I am. So I'm in Dallas. I request something that is physically stored in London, we'll say. So I go global metadata. It sends me off to London. The files are over there. How are we getting, and you said there's one region, and we will intelligently move the data around. How are we doing that? And how are we doing that in a cost-efficient way for Tigris, such that you're not moving petabytes around and incurring these crazy costs?
Yeah. So in this case, if the request is received in Dallas, we understand that the data does not exist in Dallas, and we have to read it from elsewhere. We read it from London, and so we read it remotely. The user doesn't know that the read eventually happened in London. This all happens transparently, and the read is served to the user. And then if we notice more access of that data, then we cache it in Dallas. Like if you repeatedly access the same data, then we cache it in Dallas. But then if you only access it from Dallas and hit a certain threshold, then we actually rehome it. Otherwise, we don't rehome the data.
Well, that's pretty cool. So yeah, I could have, or someone could have started by putting it in London, and then 98% of the use comes from Dallas, and
So
Tigris
it
will
will get
say,
rehomed in
"Whoops,
Dallas. Yeah.
let's move
Yeah.
this one to Dallas."
And it happens
So how
partially.
many?
There's just one thing to add, that happens partially in the sense that it doesn't happen to the entire bucket. Maybe that is only happening on one file. So only one file will get rehomed, not the entire bucket.
And so, first of all, that sounds very complex to coordinate. But how many? I guess how many copies of that could you end up with, and how do you determine? How do you, Tigris, determine like, yeah, we got to move this one to Dallas and to Melbourne, Australia? Like, what kind of heuristics are you looking at to say copy, rehome? Let's make 10 copies. Let's keep one copy. Like, talk me through some of that decision making process.
Yeah, so the heuristics basically the number of accesses and the region over a period of time. And that heuristic is used to decide when to move the file one place to another. The first stage is always to cache it, and then the cache gets TTL after some time. But if the access happens very frequently over a period of time, then the file gets moved permanently.
And you'll have to forgive me again, because this is above my pay grade and below the layer of the stack that I normally at. How fat are these pipes that you have between these data centers? And like, how many physical points do you have, or generally, if that's not something you share, I don't care, that's fine. But like, how many data centers do you have, and how are they connected such that you can economically move this data around so often?
Yeah. So we can talk about US. So we have 3 sites in US. US East 1, which is close to Ashburn. US East 2, which is Chicago, and then US West 2. San Jose, so I don't know if San Jose is US West 2, probably in AWS. Yeah. So those are the 3 sites. And then there's backbone that connects these sites. The thing about, if you think about the cost from how the cost works in the cloud model, that's not how it works in the physical model. So in the cloud model,
that's exactly
it's
what I'm
usage-based,
thinking.
right? In the cloud model, it's
Yeah.
all usage based. So you always have to pay usage-based price, which can be really, really high. But in the physical world, it's basically you pay a fixed cost for a link. So you have this backbone, essentially a link connecting the sites. It's like home internet, where you don't pay by usage. You have a link, which is a gigabit per second, right? And then you pay for that gigabit per second. You can use it 100% of the time, all days, or you use it only 10% of the time. So it's actually, pretty economical to have this sort of network connectivity between the regions. And AWS is, or the cloud just charges it for a different reason. Like that's more like the economic way to force people to run workloads within the cloud. It's like it's not that costly.
See, that's exactly my mental flaw. Is my mental model is the cloud, right? And so I'm thinking, well, S3 obviously they hold you hostage. It's expensive to get out. Cloudflare has free egress, but like, how are you doing these petabyte? And it's because you went to the pain of building your own data centers, and you've got these fat links set up, and now you can just use them or not. Who cares? You've already got them set up. And so at that point, that becomes, your competitive advantage, is you can say region is just Earth, and we'll take care of the rest of it. So
yeah, exactly. And that's why Cloudflare is also able to do it, because Cloudflare already has like a big network. They already have these pipes set up. So why not utilize it to offer free egress?
So your API is S3 compatible, but there's a lot more that you offer. So talk to me about above and beyond. So the S3 compatible is nice because I can just point my driver at your endpoint and be done with it. But above and beyond that, you've got something like small files or inline. You've got a bunch of other, we've talked about some of the branching and that stuff, but like what else are we offering at Tigris that's bringing people out of S3 to use these special features?
Yes, so a lot of these features work out of the box. So the thing that we talked about, the multi-regionality and having a single global reason, all of that is out of the box. You don't have if you use AWS SDK, you swap the S3 endpoint, the Tigris endpoint, you get all those features by default. Caching we talked about, you don't have to do anything. Small file optimization, don't need to do anything. So there are a lot of these features that are just baked in, so they don't require you to take any action. But things like, so we briefly talked about immutability and snapshot and forking, because they require a user action. A user needs to create a snapshot, right? So that's where we have, in TypeScript, JavaScript world, we have our own SDK, which not only provides a much better developer experience. It's inspired by, Vercel's Blob SDK, so it provides a much better experience as compared to S3, but S3 SDK, but it also provides functions for this functionality. Like, if I'm creating a bucket, how do I specify a source so that it forked from that bucket? Or I'm creating a snapshot, or when I'm creating a bucket, I actually want to create it from a snapshot, right? So the JavaScript SDK provides that functionality. But if you're using S3 SDK and you want to continue using it, then the way we do it is through headers. So you pass additional headers to enable functionality. Unfortunately, there's no good way to extend S3 SDK. It doesn't expose a plugin framework where you can implement your plugin and enrich it. So we have to do it through the
that doesn't surprise me at all that they don't have a plugin framework for other people to use. I want to talk about the use cases of the branching, the forking, the snapshotting, but back up just 2 seconds. We both said it, the small file thing. So tell me about this small file thing that just comes out of the box. What is it, and what is the benefit of it?
Small files. Files that are a few kilobytes, a few tens of kilobytes. These have typically been a pain point for object stores. Object stores are optimized for large objects, large files. So, and we have a tiered architecture, so we use a different storage for small files. In some cases, we inline it in metadata store. In some cases, we store it in a different log structured architecture. And that allows us to store and read these small files efficiently. Small files, typically what we have seen, they tend, like image oriented workload, they typically tend to be small files, or document, like someone is storing PDFs. Other documents, they tend to be small files. So you don't have to, if you're using S3, then you would have to use a file format like Parquet, and then you have to do the batching on the client side. So on your application layer, then you have to combine all of these files together, store it in Parquet, and then store Parquet on object store. And then you need to have metadata yourself that points to the Parquet row block inside the Parquet file, actually read it back. But with Tigris, you don't have to do any of that because of the small file optimization. You can just write the small files as many as you want.
Have you seen anybody come to Tigris or use Tigris in a clever way specifically to take advantage of this small file inlining?
There are several clever ways that we have seen people use it. So, for example, I was talking to Kurt a few weeks ago, and he told me that they use it as a document database. So they have built an internal document SDK that is using Tigris as a database. And the only reason that is possible is because the small file latency is so low that they're able to use it as a document database. So that one comes to mind. But the other, specifically small files, the other use cases like, image gen companies and training workloads, they tend to be billions of small files. So they just crank through either uploading all of these small files or doing a training run that is scanning through the small files. They benefit from it as well.
Yeah, that's super cool. And I am assuming that Kurt you mentioned is CEO of Fly.io.
Kurt, yes,
Kurt? Okay.
yeah.
I want to talk about Fly in a second, but let's go back to the branching, snapshotting, like all of that. What are some of the use cases, clever or novel, that you've seen people like to me thinking, oh, I want to branch a bucket, I can get there, but it's not immediately clear to me why I would want to branch a bucket. So what are you seeing, and what are your customers' pain points around that?
Yeah, so we are mainly seeing this benefit the agentic workflows. So we are working with a few agentic providers or frameworks, don't know what the right term is, that benefit from it. And what they want to do is, they have a bucket that's a seed bucket, and they want to have multiple agents work from there independently, right? So that's where forking helps. And then agents typically run across multiple workflow steps, and they can make mistakes. So after every, you want to checkpoint after every workflow step, right? So the check, or you might want to checkpoint as even within a single workflow step, as agent is making changes, you want to checkpoint it all. And that checkpointing is essentially creating a snapshot of what the story looked like at that point in time. So that's the more, I would say, modern use case that we have seen of it. But other use cases are more like, backup and disaster recovery related use cases.
Yeah, that's right down the middle. That's tried and true right there. How much of your business is now driven by this agentic, this AI revolution? Like, were you in the right place at the right time, and this AI stuff came along, and you're like, whoa, we could make, just a slight tweak, and maybe even just our marketing copy, and then it suddenly makes sense? How much of that is it that versus just like CRUD apps that are, S3 compatible?
So storage is such a generic product that everyone needs to use it, all types of application, right? Whether it's CRUD application, whether it is analytics related applications, or AI machine learning applications. So we have all sorts of users. We have someone running ClickHouse with Tigris as their S3 backend, and we have people storing receipts, or people storing, AI generated images, or people storing videos for training. So we have all sorts of use cases, but I would say that majority of our success, or majority of our scale needs come from AI use cases, from whether it is training workflows, inference workloads, or it's agentic workloads. So that I mean, if you look at our website as well, it talks about the features from the AI lens. Like if you're a machine learning engineer or AI engineer, what are you actually looking for storage? And then we highlight those features, because that's where we seem to be hitting really well with our feature set and differentiators.
Did that catch y'all by surprise when I imagine there was a shift from non-AI to AI being the primary, business driver? Did that catch y'all by surprise? Was it inbound where people were like, oh, turns out this is perfect?
I would say it's a mix of both. So the distributed nature of storage, I mean, it just makes a lot of sense. It was easy to sell to people, or it was easy to market to folks who are using the neo cloud. So it sort of made sense what we are doing. I would say it's a mix of both. Like if if the distributed compute revolution would not happen, and all of the world's IT is only three companies, then yes, it would never happen. But I had thought that we cannot live in a world where there are three companies and they are the only ones running IT, and everyone is dependent on them. That should not happen first. And then my thesis was that this is not going to happen. People want to have best of the breed services, and there are many companies that are succeeding with that. That have succeeded, right? I mean, look at Snowflake. They beat Redshift. Look at Databricks. Look at PlanetScale. Look at Confluent, right? So, or WebStream, right? Cloud is more of a control plane around all of these open source products, but actually the expertise lies with someone else who is able to build a better product. And so we want to do the same thing, like build better storage, because we want to be hyper focused on storage. We don't want to wander off and do other things. Just the Unix philosophy: do one thing best.
It does seem like the wandering off gets a lot of companies in trouble. Just observing from the outside, it seems like the wandering in the desert is not a good idea. The first time I came across Tigris was through Fly, and so you mentioned Kurt earlier. He's the CEO of
Yeah.
Fly.io, which is also building their own cloud and going against the big dogs. And I from the outside, it makes a lot of sense to me that you all would be friends because Fly's got these, micro machines all over the world. And if you have compute everywhere, well, you still got to read the stuff, right? You got
Yeah.
to get the storage everywhere. Talk to me about kind of that partnership because I believe it's more than just like coincidence. Like y'all are actually formally partners, right? And so
Yeah.
talk to me about how that came along and kind of the story there and why that makes so much sense.
Yeah, so Fly is one of our very early partners, and really grateful for that, for them partnering with us. And we have a very tight integration with Fly. We also run for Fly customers. We run Fly users. We run some of our stack inside Fly to be able to offer better latency to Fly users. But yeah, we have very tightly integrated. We are part of a developer's workflow of creating a Fly application. It's very easy to create a bucket to go with your application. It's all integrated. You can you even things like your bill. If you're a Fly user, then you log into Tigris through the Fly SSO. You get billed through Fly. You use Fly CTL. So it's all very tightly integrated with Fly. It doesn't look like a separate product or a separate company.
Yeah, that's super cool. That reminds me of the Heroku glory days, the centralized billing where you can have the add-ons and it's all SSO straight through. Are there other you talked about we can't live in a world where it's just the big three. Are there other companies like Tigris and like Fly that have kind of like banded together to, build out their own clouds and stuff like that? So are there other companies you're partnering with in the same way that you've partnered with Fly?
So they are our customers generally run in these other companies. Our customers are running in CoreWeave and Together AI and Lambda Labs and Voltage Park and like all of these other clouds. So we do have customers running there. We don't have formal relationship with those compute or GPU providers, but our customers use us there heavily. But we want to have more relationships, similar tighter integration with other providers as well, and then we'll focus on that angle. Right now, we are just focused on serving the users as they are coming to us, but we have to focus on the partnerships more. I think it's a good way to grow.
So talk to me about the users that are coming to you. So give me a sense of the size, either employee number or anything you want to
Yeah.
give me a sense of size for the company as it exists and some sense of like growth trajectory. Anything you
Yeah.
feel comfortable sharing to put that in perspective.
Yeah. We are doing really well with media-oriented companies, and some of the names I mentioned earlier, but the media Gen AI related companies that are well known or that are building either their own video models or that are building inference platforms, they are our customers like FAL, and we are doing really well with them, and they are growing at a massive rate as well. So we are not focused yet on traditional enterprises. Traditional enterprises kind of move very slowly. But when you look at the spend of the AI companies and the amount of capital that has gone in, their spend actually is equivalent to an enterprise spend on an account by account basis, right? So I would say that we have enterprise customers. We have these new digital first AI enterprises, and that's the success. Those are the companies that we are seeing success with. So that's one end of the spectrum. The other end of the spectrum is people building their applications, and this can be any type of application. A lot of users come through Fly as well.
So you mentioned like staying focused, not getting distracted. But what is I imagine you have a vision for 3-5 years from now? Like, what do you see as the next like leap for Tigris, or the thing that like in your heart you want to solve, but it's not time to do it yet? What do you see the future looking like for y'all?
Yeah, so it is all centered. It's all going to be centered around the storage. That's what I mentioned. That we don't want to wander off and do other things. Like we want to focus on storage, and we want to provide the best experience for the two most popular storage interfaces. So one interface is S3, which we're already working on, and then the other interface is file system. So the next thing for us is to build a distributed file system that can scale as the user grows, that does not have the operational overhead that file systems typically have. So that's the next thing that we want to solve, is to provide a high performance scalable file system that uses object storage as its backend, but the focus is going to continue to be on the storage front.
I love that. That is that sounds very similar to what we've just seen PlanetScale do, which is like, we're going to continue to focus on these, high availability, production critical database workloads. But, we can also tackle Postgres as well. That's still within our mandate. And that sounds like you're staying within the storage mandate, but you want to do, you want to keep fulfilling that duty to storage. And the next one is file system, which sounds like a lot of fun and sounds like a lot of work.
It is a lot of work, but storage itself is a lot of work, because look,
that's what I was gonna say. Yeah,
people trust us with durability, right? Especially when you're using object store, you never think about you are storing. I mean, your backups, your disaster recovery stuff, right? So people trust us, so we have to continue focusing on durability and reliability. And we so far our track record has been, I would say, top notch. We haven't had any durability or reliability issue or incident, and we need to continue focusing on that. So storage already is a hard thing to do. So that's why we want to focus on storage, and file system is another piece that should be solved, and so that's why we want to solve it as well as another common interface for accessing storage.
Yeah. So that was one thing that struck me, is like, maybe I should, but I don't think about S3 losing something. I just don't think about it. And I feel like you have to reach that bar as well. And so as we wrap here, I want to kind of get like, what has been the hardest technical challenge of building this thing out in a way where you can confidently go to the market and say, yeah, we're an alternative to S3. Like, technically, what has been the biggest hurdle there?
I mean, technically, everything is it's hard.
Pick five. I don't care.
Right?
Tell me.
Yeah, I mean, look, S3 provides consistent latency. We have to provide consistent latency, right? S3 provides unlimited scale. Like, you don't think about calling AWS and say, I need more capacity.
No, of course not. No.
Right? So we have to be that unlimited storage. That's the biggest challenge, I would say, that we have to be that unlimited storage where you can just keep scaling at your whim. You need more RPS, you keep getting more RPS. You need more storage, you keep getting more storage. And then combine that with, running our own data center, having our own hardware, which I think is important for us to do, because without it, we cannot offer the pricing that we're offering right now, and the performance that we're offering right now. So yeah, so it's all a challenge, man. I mean, S3 is unlimited storage.
All of the challenges, yeah. Okay, so we're close to the end here. So tell the people listening, give us do you need anything? Do you need open source contributions? Do you need people to apply to work there? Do you need people to try out certain things? And what would be, I guess, your advice, and we can end on that one, your advice for somebody setting out from a big company that like wants to go out into the brave startup world? So first, give us a call to action for how people can help, and then leave us with something where it's like, hey, I want to do the same thing that y'all did.
Yeah. So the first thing I would say is that try us out. It's very easy to get started. Create your account, create a bucket, try us out, and provide us with feedback. We are very much feedback driven. So if you'll provide us with feedback to help us improve the product, you will see it happen very quickly. The second thing I would say is that the snapshot and forking feature that I talked about It's not publicly released yet, and we'll be releasing it next week. So please try it out, and share feedback and let us know what more we can improve on the API side of things, or with that particular feature in general. And we're always looking for great backend engineers, infrastructure engineers, and we are solving a very hard problem, and it's hard, challenging, but also that also makes it enjoyable. So we're always looking for great people to join our team, and those are the two things. And the last thing was the advice for someone starting.
You left presumably a wonderful job at Uber that you loved, and you set out into this brave world. So what would you say to an engineer listening right now that's like, I kind of want to go down that journey?
Yes. So what I would say is that, and what I've learned is that, first sell your product, then build it. If you come from a big company, especially, and you've solved problems at a big company, more often than not, they don't apply to the outside world as is. So first, do your market research and sell your product, have customers who are willing to pay for it, or who are willing to use it in some of a production environment, and then, then build it out. That's the lesson I learned.
Yeah, spoken like a true not engineer. So you're a proper CEO now, because an engineer would say, I'm gonna build it all, and then they'll come. But
I build stuff as well. I still build
you learned that
stuff.
lesson the hard way.
Yes, well, I still build stuff, but I learned that, like you said, I learned the lesson the hard way, right? And I just felt like, that's something that I tell anyone who is starting a company, that this is what you should do. Otherwise, you will end up learning the same thing on the job.
This has been just a delight. I could have you back on and we could talk for another hour. This has been so much fun. Where do you hang out online? Where can the people connect with you? Is it Twitter? Is it LinkedIn? Tell the people where they can find you.
You can find me on Twitter and LinkedIn, but you'll find me more on Twitter. I'm
Man after
available
my
there.
own heart.
I follow you as well, and I'm just there, available. Anyone can reach out to me and talk to me.
Wonderful.
And happy to help with anything at all.
Okay.
Anything I can contribute to the community.
Yeah, thank you so much for doing this. We'll leave links to all your stuff, including your Twitter profile and obviously all the company stuff. We'll leave links to all that down below. And thank you so much for taking the time to come on and talk to everybody. And for the dear listener, thank you for joining us. If you're watching on YouTube, please subscribe. That helps a whole lot. And if you're listening on audio, I guess thanks. You could also subscribe on YouTube. Why not? What the heck? But both versions are available, so depending on your preference, you could find either one. And you can find all of that at databaseschool.com. And my ask for the audience is the way that Ovais ended up on this podcast is the way that everyone ends up on this podcast is through serendipity. So if you know somebody that has cool stories to tell, send them my way. I would love to talk to more people. So thank you again for doing this, and thank you all for listening, and we will see you next time.